All right, so today we're going to take a look at our third conic section and deal with ellipses. For starters, our formal so we're on page 9, by the way, of your packets. For starters, our formal definition of an ellipse is the set of all points x comma y in a plane where the sum of the distances from two fixed points, which we'll call foci, is constant. Where the sum of the distances from two fixed points which we're going to call foci, is constant. An ellipse is defined as the set of all points x comma y in a plane where the sum of the distances from two fixed points is constant. By the way, please, throughout this video, pause when you need to. I'm not really sure if I'm going too fast or not since there's no one in front of me right now, so please pause to make sure you're all set and ready to go. Here's how the actual definition works. I've got 2 points over there, which are my two focuses, my foci. I got a point over there on the ellipse. My definition is saying this distance plus this distance, well, that's the same as this distance plus this distance, which is the same as this distance plus this distance, and so on, to create all the points around that ellipse. I'd like you to take a moment, pause the video, and take a look at the first the first GeoGebra demo that I put in Classroom, where you can kind of mess with the foci on an ellipse and see that the sum of the distances really is the same for every point along a particular ellipse. Please pause the video and go check that out. So now, to actually deal with formulas for ellipses and all that, I need a couple variables here, a couple constants here, actually. The center of our ellipse will be h comma k, just like our center for a circle, just like the vertex for a parabola. Over here, I have my center. That's h comma k. A circle has one radius. Here, well, the distance is different from there to there, versus from here to here, versus from there to there, and there to there, and all those distances from the center are different. Instead of talking about a radius, I'm going to talk about what we call the major axis and the minor axis. The major axis will be the longer axis. The minor axis will be the shorter axis, both of which pass through the center. I'm going to let the constant a be the distance from the center to the end of the major axis. A is the distance from the center to the end of the major axis. You know, before doing that, I probably should have highlighted the fact that this thing over here, that's my major axis. And the major axis is always the longer one. Well, just like I have a major axis, I have a minor axis, my shorter axis. We're calling this one over here the minor axis, and that is always the shorter one. Now, I'm not saying that the shorter one is always the vertical one, the longer one's always the horizontal one. We'll mess with those things in a moment, but the major axis is the longer one, the minor axis is the shorter one. I'm going to let b represent the distance from the center to the end of the minor axis. couple other important features over here. The points at the end of the major axis we call the vertices. So I have two vertexes, one over there, one vertex over there. There is another point. There are two other points lying along that major axis. Those 2 points are our foci, which relate back to our formal definition of an ellipse. I have a focus over there, and I have a focus over there. And I'm going to create one other constant, c, which is going to be the distance from the center to the foci. This distance is the same on this side and this side, so it's the distance from the center to the foci. By the way, that distance is always along the major axis. The foci will always lie on the major axis. I have one other important relationship between A, B, and C. Actually, before I do that, the major axis is always the longer one. Because of that, I'm going to try to squeeze two little things in over here. A is always greater than B. I guess we could say greater than or equal to B, but if they were equal, what shape would it be if the major axis and minor axis were equal? I hope you just said circle. We have a relationship between the C and the A and the B. And my relationship is C squared equals A squared minus B squared. In the interest of time, we're not going to go through the derivations of these things. We're just going to see how to work with these formulas. I want to deal with two different cases of ellipses here. The ellipse where our major axis is horizontal, and the ellipse where our major axis is vertical. The equation of our ellipse, if the major axis is horizontal, will be x minus h squared over a squared plus y minus k squared over b squared equals 1. Now, to show you where these things show up in our picture, that center, that's h comma k. A is the distance from the center to the end of the major axis. So that distance over there, that's A. B is the distance from the center to the end of the minor axis. That's B. And the distance from the center to the focus, that's C. Let's keep going with analyzing this ellipse, and then we'll switch over to the vertical ellipse. The center of my ellipse is h comma k. The length of the major axis, well, if the distance from the center to the vertex is a, the entire length over there is going to be 2a, because you've got to get this and that. Similarly, the length of the minor axis is 2b. The coordinates of my vertices, well, I'm taking my center, I'm adding my a value, my distance from the center to the vertex, and I'm subtracting my a value, and I'm applying this addition and subtraction to, if I'm dealing with our horizontal ellipse here, the x value, the h value. My vertex is h plus a, comma k, and h minus a, comma k. The coordinates of my foci will work in a similar way. I'm going to take my center and add my distance to this focus and subtract the distance to get to that focus. I'm going to add c and subtract c and say h plus c, comma k, and h minus c, comma k. Like comments I made yesterday, things like these formulas are not super important for us to memorize. It's more important that we can just sort of visually look at an ellipse and figure out the pieces that we need. We're going to do a lot of work by looking at graphs of these things. If the major axis is vertical, my equation will look like x minus h squared over b squared plus y minus k squared over a squared equals 1. My center is once again h comma k. That's a little bit tricky to see, but that's h comma k. The major axis this time is vertical, because that's the longer one. Distance from the center to the vertex is a, so the entire length of the major axis is 2a, just like it was for the horizontal ellipse. Distance from the center, well, to the end of the minor axis is b, so the entire length of the minor axis is 2b. My vertices are always at the end of the major axis, so here's a vertex and there's a vertex. To give the coordinates, I'm going to add and subtract a, but this time I'm going to add and subtract that from my y-coordinate of the center. I'm going to have h comma k plus a and h comma k minus a. The foci, well, c is that distance from the center to the focus up there, same distance from the center to the focus down there. So my coordinates will be h comma k plus c and h comma k minus c. And once again, way more important than memorizing these things is being able to visually work with these and figure out the pieces by looking at a graph. These equations will need to be memorized. Let's see how to do some graphing. And of course, if you're not ready, push pause and make sure everything on here is perfect in your notes. On the next page, we're going to graph and analyze two ellipses. Let's start by graphing the ellipse x minus 1 squared over 9 plus y plus 2 squared over 4 equals 1. I'm going to start by finding the center of my ellipse. Well, h, k, my center is 1 comma negative 2. I'm going to put a point at that center, 1 comma negative 2. Before I go on and deal with the rest of this, I'm going to try to get my graph. My major axis, well, the distance from the center to the edge of the to the end of the major axis. Hold on one moment. I want to stop my phone from dinging. Okay. The distance from the center to the end of the major axis is the square root of this number over here. Remember, our formula had an a squared. So that distance is going to be 3. I am going to go in the x direction from my center, 3 units out this way. 1, 2, 3. I'll put a point there. That'll actually be one of my vertices. And I'm going to go out 1, 2, 3 in the other direction. This thing squared is the a value. My a value is just 3. My b value, well, this thing is b squared, so my b value is 2, which means from the center, I'm going to go up 2, and I'm going to go down 2. And I think I now have enough information to graph my ellipse. I'm just going to connect those 4 dots with an oval shape. And my ellipse is looking like that. Now, we're going to go do the analysis. The length of the major axis. Well, here's my major axis. It's the longer one. I know the a value is 3, so my length is 2 times 3. My length is 6. Length of the minor axis. Here's my minor axis. I know from the center to the edge over there is a distance of 2, so that entire minor axis is going to be 2 times 2, or 4. The vertices are at the end of the major axis. Here's my major axis. Here's one vertex, there's the other vertex. Our vertices are going to be 4, comma, negative 2, and negative 2, comma, negative 2. Finally, the foci, which I don't necessarily need to be able to graph this thing just using the equation. I need them to do like the formal definition with the sum of the distances and all that stuff. We have a formula to find our c value. I think once we have the c value, we should be set. We're going to use the formula c squared equals a squared minus b squared. C squared is going to equal a is 3, so a squared is 9. B is 2, so b squared is 4. C squared is going to equal 5, which means c equals the square root of 5. What this means is from your center, you have to go root 5 in this direction and root 5 in that direction to find the foci. Well, to give the coordinates, I'm going to take my center, I'm adding root 5 and subtracting root 5, and I'm doing that to the x coordinate. So I'm going to get 1 plus root 5, comma, negative 2, and 1 minus root 5, comma, negative 2. Let's try this with another ellipse. Let's try this with x plus 1 squared over 4 plus y minus 4 squared over 25 equals 1. First, get the coordinates of your center. Center should be negative 1, comma 4, negative 1, comma 4 over there. Negative 1, comma 4. Now, one of the nice things I think about ellipses is I don't have to know right away if it's vertical or horizontal. All that I need to know, I guess, is the thing below the x's is the square of how far you're going from the center in the x direction to the ellipse, and the thing below the y piece is the square of how far you're going from the center in the y direction to get to the ellipse. So over here, 4 is 2 squared, which means in the x direction, I'm going out 2. I'm going out 2 from the center. Below the y piece, I have 25. That's 5 squared, which means in the y direction, I'm going out 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Connecting the dots, I get my ellipse. For my ellipse, a is always the square root of the bigger number that we have over there, which means my a value is 5 and my b value is 2. I'd like to see if you can pause the video and go do the analysis down here. Please actually do pause this. You're going to learn more by you trying it rather than just watching me do things. So please pause and go. Length of the major axis. Well, here's my major axis. I know my a value is 5, so my entire length is 2 times 5, or 10. Length of the minor axis. I know I'm going up 2 units over there, so the entire minor axis is 2 times 2, or 4. Vertices are at the end of my major axis, so I see one over there and I see one down there. I think those look like negative 1, comma 9, which I'm also getting by just taking my center and adding 5 to the y coordinate, and negative 1, comma, negative 1. As for the foci, I need to use my c squared equals a squared minus b squared formula. C squared equals 25 minus 4. C squared equals 21, which means my c value, the distance you're going to go out from the center to get to each focus, is the square root of 21. That has to be along our major axis, so I'm going to add that and subtract that from the y coordinate of my center, and I'm going to get negative 1, comma 4 plus root 21, as well as negative 1, comma 4 minus root 21. So this is the graphing piece. Next thing we need to do is, if I give you information, we need to be able to write the equation of the ellipse. We're going to take a look at 2 of those. On the next page, I want to write the equation of the ellipse with foci at 0, comma 1 and 4, comma 1, and a major axis with a length of 6. Just like yesterday with our parabolas, we're going to deal with this in a visual way. I want to draw some axes and I want to plot those foci and then try to figure out all the other pieces that I need. I think I just need my center, my A, and my B, and I'm good. Let's graph some small axes over here. Zero, comma 1 is right over there. 4, comma 1 is right over there. And I'm going to put little f's by them just to note that those are foci. Can you figure out the center of this ellipse? Well, the center has to be exactly halfway in between those foci. My center is going to be right over there. My center is going to be 2, comma 1. Now, my major axis has a length of 6. Well, I know my major axis has to be horizontal because the foci always need to be along the major axis. I am going to go from the center let's see, if the major axis has a total length of 6, then from the center to each vertex needs to be a distance of 3. 1, 2, 3, there's a vertex. 1, 2, 3, there's another vertex. I am almost there. I know my A value. My A value is 3, because from the center to the end of the major axis, that's going to be 3, because the entire length is 6. My B value, I don't know that yet. Hold off on that one. But I do know the C value, which I can use to help me get my B value. The C value is the distance from the center to the focus, so I think my C value is going to be 2. Well, to find the B, I know that C squared equals A squared minus B squared. I know that 2 squared equals 3 squared minus B squared. 4 equals 9 minus B squared. Subtract 9 divided by negative 1, B squared is going to equal 5, which means B will equal the square root of 5. Although, honestly, I care more about B squared than B, but that's okay. B is square root of 5. And we'll go out something like this. I think I probably have everything I need, though, to be able to graph the rest, not really graph, but write the equation of my ellipse over here. I'm going to say x minus 2 squared over, I'll get that in a moment, plus y minus 1 squared, I'll get that in a moment, and that's going to equal 1. In the x direction, I'm going out my A value. I'm going out to the end of my major axis. I'm going out 3, so I'm going to put 3 squared, or 9, in the denominator. In the y value, I'm going out my B distance. I'm going out square root of 5, which means B squared is going to give me 5. This is how I'm piecing these things together. My ellipse will be x minus 2 squared over 9 plus y minus 1 squared over 5 equals 1. Let's take a look at another, writing the equation 1. The focus is 3, 2. The center is 3, 5. And I want the minor axis to have a length of 4. Please go graph those 2 points. Focus is 3, 2. My center is 3, 5, so 2, 3, 4, 5. Okay. And I think that's all I'm going to do for right now. Actually, no. I can do some work with that minor axis. I know since the foci always lie on my major axis, my minor axis has to go the opposite direction. My minor axis will be horizontal, and I think I need to go out 2 spaces in each direction to get there. I'm not going to give these special names. I think in Algebra 2 you might have called them co-vertices or B points or something like that. I'm just going to label them, and not label them, graph them, and just move on. And I think I already know my B value is 2. Well, I only have one focus, but I think that's okay because all I really care about is the distance from the center to that focus, and this distance looks like 3 to me. If I wanted the other focus, I could go up 3 spaces, although I don't think it really adds much to my understanding of this problem. And then I need to figure out my A value, and then I'm pretty much good to go. I'm going to use my formula C squared equals A squared minus B squared. 9 is going to equal 4 minus B squared. Wait a minute. No, it's not. We're going to try that again. Sorry. It's going to equal A squared minus 2 squared minus 4. A squared is going to equal 13, which means your A value is the square root of 13. You're going to go out root 13, both up and down, to get to the vertices. I don't necessarily need those there. I think we have everything we need to be able to write the equation of this. Pause the video and see if you can make your equation. Okay, I'm going to say x minus 3 squared over something plus y minus 5 squared over something. This is going to equal 1. Well, in the x direction, that's my minor axis. I'm going to put a 4 below there, my 2 squared. I'm going out 2 units from the center to the end of the minor axis. I'm going out root 13 to get to the end of the major axis, so I'm going to put square root of 13 squared. I'm going to put 13 in that denominator. That should be your formula. The last thing that I need to show you is the completing the square work. We're going to complete the square on 2 of these, do some analysis, and be all set with this, and you can spend the rest of the period working on the homework or on the final exam review. Let's look at x squared plus 4y squared plus 6x minus 8y plus 9 equals 0. The first thing I'm going to do is I'm going to group my x terms, group my y terms, and put my constant on the other side. I'm going to get x squared plus 6x plus 4y squared minus 8y, and on the other side I have negative 9. Now, I can only complete the square if there's a 1 before my variable squared. I'm good here, I'm not good over here. We're going to factor out the 4. And I'm going to make it x squared plus 6x plus 4 times y squared minus 2y, and that equals negative 9. Now it's time to do the completing the square work. X squared plus 6x plus something plus 4 plus y squared minus 2y plus something is going to equal negative 9 plus something plus another something. Okay, same deal as always. Half that middle term squared is what we're going to add. Well, half of 6 is 3. Squared gives me 9. I'm going to add a 9 there. I'm going to balance that out by adding a 9 on the other side. Doing the same over here. Half of negative 2 is negative 1. Squared gives you positive 1. I'm going to add a 1 there, but I'm not going to add a 1 on the other side. This is important. This isn't actually a 1 that I added. I didn't actually change my left side by 1. I actually changed my left side by 4 times 1, or 4, which means to balance it out, you're going to have to add 4 on the other side. If you don't believe this, remember you can always distribute the 4, combine like terms, move this back to the left, and yes, you will get that original problem back. Now we can factor. This is going to give me x plus half my middle number before any squaring is 3, so x plus 3 squared, plus 4 times y, half my middle number is negative 1, y minus 1 squared, and on the other side, we're going to get 4. I'm almost there. An ellipse has to equal 1. I'm going to go and divide all 3 pieces by 4, and this gives me x plus 3 squared over 4 plus y minus 1 squared over 1. I'm going to include the over 1 just because it'll help me with a few other pieces in a moment, equals 1. Now, to do all this analysis, I gave you formulas on the first page. I'm not going to use any of those right now. I'm going to graph my ellipse and then pick out the important information from there. So I'm going to draw some small axes over here. 1, 2, 3. 1, 2, 3. Center is negative 3, 1. So there's my center. I might as well fill that in, negative 3, 1. I know that in the x direction, I'm going out 2. 1, 2, 1, 2. In the y direction, I'm going out 1. Up 1, down 1. There is my ellipse. How about you pause the video and now try to do length of major axis, minor axis, vertices, and foci, and for foci, you got to find your c value. Pause this. Again, please actually do pause it and try that. Distance from the center to the edge of the major axis is 2, so the entire length of the major axis is 2 times 2, or 4. Distance from the center to the end of the minor axis is 1, so length of the minor axis is 2 times 1, or 2. My vertices are here and there at the end of the major axis. That looks like negative 1, 1, and that looks like negative 5, 1. As for the foci, c squared equals a squared minus b squared. C squared equals 4 squared minus 1 squared. C squared equals 16 minus 1. C squared equals 15. So C equals the square root of 15. Remember, these are always along the major axis. So I'm going to take my center, I'm going to add my C value and subtract my C value. And I'm going to get negative 3 plus root 15, comma 1, and negative 3 minus root 15, comma 1. Let's do one more of these. Let's look at the ellipse 25x squared plus 16y squared minus 200x plus 96y plus 144 equals 0. Group your x's, group your y's, move your constant to the other side, and then factor out the value before the x squared and the y squared. Pause and see if you can deal with that. Okay, I'm going to take out a 25 and say 25 times x squared minus 8x. And I'm going to take out a 16 and say 16 times y squared plus 6y equals negative 144. By the way, I've got to see this stuff. I've got to see you factoring things out, what you're adding in here, how you're balancing it on the other side. I got to see the algebra work on here. 25 x squared minus 8x. I'm going to complete the square in a moment. Then 16 times y squared plus 6y plus something. I'll complete the square there in a moment. Negative 144 plus something plus another something. See if you can figure out those two numbers. Pause and get those. Half of negative 8 is negative 4. Squared gives you 16. Half of 6 is 3. 3 squared is 9. Now, this isn't actually a 16. It's really a 16 times 25. 16 times 25, I'm going to get 400. This isn't really a 9. It's really a 16 times 9, or 144. So I'll go add that. And this is going to give me 25 times x minus 4 squared plus 16 times y plus 3 squared equals, well, that's nice, those cancel, and we get 400. I'm going to divide everything by 400. $25 divided by 400, well, you can divide both of those things by 25, and you're going to get 1 over 16. You're going to get x minus 4 squared over 16. Next, I can divide both of those things by 16 to simplify that fraction. 400 divided by 16 is 25. Oh, that's so nice. It's almost like I tried to make these things perfect squares. I'm going to get a 16 there and a 25 over there. What I want you to do now is pause the video, do a small sketch of that ellipse down here, and then do all of your analysis. Please, again, actually pause it and do it, and then restart, and I'll show you my work. Okay, let me see here. 4, negative 3, that's over there. I'm going to go out 4 in the x direction. 1, 2, 3, 4. 1, 2, 3, 4. I'm going to go out 5 in the y direction. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. My ellipse, almost circular. I'm going up 4 in one direction, though, and 5 in the other, so it truly is a true ellipse, not a circle. My center is 4, negative 3. Major axis, in this case, that's the vertical one. 2 times 5, your length is 10. Minor axis, the horizontal one, 2 times 4, that's 8. Vertices, here's a vertex, there's a vertex. I'm going to, let's see, where is this? This looks like 4, 2, because I'm going out 5 from my center. And I'm also going down 5 from there, so 4, negative 8. The foci, c squared equals a squared minus b squared. C squared equals 25 minus 16. I think this is actually going to be really nice. C squared equals 9, which means c is the square root of 9. C is just 3. I need to go from my center 3 up and 3 down to get to my foci. Well, 1, 2, 3. One focus is there. 1, 2, 3. One focus is over there. My foci are at 4, comma 0, and at 4, comma negative 6. We got one last conic we're going to deal with. Next class we'll deal with hyperbolas. We're also going to do a very, very short quiz next time on the homework that was due today, the parabola and circle stuff. And that's what I've got. You can spend the rest of the period working on either the ellipse homework, or if you'd rather work on the final exam review, you can do that as well. See you next class.